Alright guys, let's take a look. Let me catch up to you. I'm going to start down here at this one. Oh, I'm sorry. So guys, let's take a look. So a real quick check is that these have to add up to the same as these, right? Don't put 48 here. What'd that person do who put 48 here? Added everybody twice. That's crazy. So what's the straight up, if I pick one person from this group, what's probably their man?
6.
Out of? Yes. So if you say 6, what's wrong with that? What's the largest that a probability can be? You know this. What's the most, what's something that's definitely going to happen? What's the probability of it? 100%. I was talking just in general, right? You guys understand. So if your coach says give it 110%, that's mental, right? Not like that's mental, but it's all mental. You can only give 100% mathematics. So if there's a 120% chance of rain tomorrow, what the hell would that mean? Like super rain? I don't know what that would mean. So if you put an answer down for a probability and say 6 or something, I'm going to cry a little bit because your answer can't be bigger than 1. 100%, right? So 6 men out of 24 people, and of course that is 25%. How many said no? 6 out of 24, so that's also 25%. So if you're worried you got the same answer twice, you shouldn't be. Now again, everybody has trouble with the or. I wish I could make it. You can either follow the formula we got. It'll actually work pretty decently. Or you can just be smart about, I want to count all the females. I also want to count all the what the hells. Yeah. All the what the hells. But if I count all the women, how many what the hells have I already counted? 10. So I can count all the women, 18. Plus, how many what the hells have I not counted yet? 3.
Oh, 3.
Guys. So one way to do this is to say there's 18 women plus 3 more what the hells I haven't counted yet out of 24. Or you can say, okay, 18 women, 13 people that said what the hell, but then I've double counted how many? 10. And what is 13 minus 10? Freaking 3. Right? So either way you do it, you'll end up with the same answer.
87.5%.
87.5?
Yes.
But if you do 18 plus 13, what's that? 18 plus 13.
We count 31.
31 divided by 24 would be bigger than 1. The problem is trying to tell you, hey man, you made a mistake. So don't just put that answer down and keep going. Again, that will bring tears. The tears of a math teacher. And there's no one of them. That's an old song, sir. That, on part D, what's going to be on the bottom on part D?
24.
Still 24, because I didn't tell you a damn thing about the person. I'm saying, what's the probability they said yes? And that they're a female?
4.
Okay, there's 4 people that are both, right? 4 females said yes, so there's 4 people that match everything everything I need. And that's like 16.6666, right? Remember that bar?
Yeah.
That means repeating? Or you just make it 16.7 and round it. Alright. By the way, let me make this point right now. Your work, when I say show your work, and I wear my stupid little shirt and all that kind of business, this is your work. setting up the ratio the way it is originally. And then if you reduce it, make it a decimal, that's what you do with it. But this is your work. If you don't show me that and you get it wrong, you're going to lose all the points because I don't know what the hell you did. So if you show me that, you'll probably get some partial credit at least. All right, now here's the first one where I actually give you information. So what's going to be on the bottom for this one now?
18.
I know that they're female, so it's got to be out of these 18 people. And you can actually do this. You can just do this. Out of those 18 people, how many said yes?
4.
4. So 4 out of 18 women said yes. And what does that become?
22.2.
22.2 forever. So same thing for part F. What goes in the bottom now?
6.
Yeah, there's 6 people that said no. Out of those, how many are men? 2. So that's like 33.3. Now. Let me talk about the last problem. Let me talk about the idea of the last problem. Let me see if you guys are with me. One time I had this girl get really angry at me for saying this. So let's see what happens. If I see somebody off in the distance walking towards me, they're just too far away. I can't really tell if they're a man or a woman yet. They're just too far away. What's probably they're a man? What's probably they're a woman? 50%, roughly, right? What if I happen to catch the fact that they just got off a Harley-Davidson motorcycle? So given that they got off a Harley-Davidson motorcycle, is the probability that they're a man still 50%?
Yes.
No. What's happened to that? The probability that they're a man should increase. Right? Alright, let me try another one. What's the problem? Alright. So, if you took a 7 a.m. class, have you ever taken a 7 a.m. class? It's awesome. I love it. Guys, stay with me. The probability that you make an A on the test is something, right? Let's say it's 50%. Given that you went out the night before, did a lot of drinking, and got 47 minutes of sleep, will the probability that you'll make an A on the test stay the same? Okay, good. I was worried at first. Why did it change? Because the given information makes it change the probability that you're going to get an A, right? Your probability should go down. Let me stop there. Is everybody cool with that example? What's happening? Some of you guys are just looking at me. Move your head in one direction or another for me. Does everybody understand that idea? Yes?
Is it because, even statistically, men have more Harley Davidsons than women?
Yes. Who rides Harley Davidsons more? Men or women? Men. Now. No. See, this is exactly what happened. Girl got really upset at me. She says, I ride Harley Davidson. Are you saying no women? I never said no women ride Harley Davidsons. Who rides Harley Davidsons more? Men or women? Men. I love it. You know people that ride. I know women that ride Harley Davidsons. There's a gang of them over there. But still, who rides them more often? Who owns Harley Davidsons more? Men or women? Men. And I am not saying that women aren't good enough to ride on a freaking bike. You guys understand what I'm saying? I'm not saying that no women ride it or anything like that. I'm just saying the numbers are what they are. That's all I'm saying. And I agree with you. More and more women are riding. But there's still a ton more men that are riding them than women. So if I saw somebody and they got off a Harley Davidson motorcycle, I'm like, is that a man or woman? The probability their man is gone up because they came off a freaking Harley. Does it mean they're definitely a man? No. The probability went up. So see, we hear something that I didn't say. And that's the brain not capable of understanding probabilities. We're not hardwired to understand them. But if I say the probability of this is this, it doesn't mean that's definitely going to happen or something. Unless I said it's 100%. Because it's just that the probability of a man is not 50% anymore. It's gone up from there. What is it now? I don't know. I have to know the numbers, but I know it's gone up. You guys?
Yes.
I know you got it. But not everybody. Some people are still looking at me like, I want to hurt you. Don't hurt me, please. All right. So, this is the idea of independent. So would you say that being a man and riding a Harley Davidson are independent or dependent? So what I mean by that is, if I knew that one was true, would it change the probability of the other one? That would be dependent. So the probability of man, does it depend on if they just got off a Harley Davidson or not? Yes. So that would be dependent because of this. So the probability of man, we said, was 50%. The probability of man, given that they got off a Harley Davidson, would be higher than 50%. Whatever, let's say 80%. Probably more than that. But I'm just trying to keep from getting beaten by a group of women later. All right. Are you the guy? Is this the same class that misheard me say corn at one time? Oh, I got a great semester going. He's talking about porn. He's saying women can't ride bikes. What is up with this guy? Get rid of this guy. All right. All right. So, if I say, tell me if event A and event B are independent, you do this test. Test for independence. If the probability of A given B equals the probability of A. Now think about what I just said. Given that B happened, the probability A doesn't change. I would call those independent. If you're independent from somebody else, do you depend on me? Oh, yes, you do. A little bit, right? But do you depend on the person who's just now getting off the boat? Depends. Do you depend on this person who is currently in Antarctica? No. So if they have a cold, will that affect you at all? Will that make the probability that you get an A on a test different? No. So those are independent. You're independent from that person. So that's what this is saying. Given that this person has a cold, the probability I make an A stays the same. They're independent. If this was not equal, if I said given that this happened and the probability of A changes, then they would be dependent. Depending on whether B happened, the probability of A changes. So let's look at this problem. I'm asking you, are being a man and saying no independent events? So what's the probability of a man? We calculated that. What's the probability of being a man from the sample? No. 25%. 6 is way too big. You're telling me there's a 600% chance that I got a man, and it's like, I pick one man and he splits into 6. I don't know what that means. Right? Think about it. Why are we dark? So the probability of a man in this sample is 25% chance. What's the probability of a man given, I'm using a symbol. I'm going to show you that symbol. Given that they said no.
33.
We calculated that one too, didn't we? 33%. Did the probability that they're a man change if I tell you they said no? It was 25%. Now it's 33%. So if I know the person said no, the probability they're a man just went up. So are they independent or are they dependent? Do they give a shit about each other or not? If one happens, does the other one change? Yes. Doesn't that feel like the definition of dependent in real life? Right? If I tell you a bunch of made up shit about math, and then I give you a test, will you do well on that test? No. Right? So you depend on what I say, unfortunately. Sorry. I could go crazy any moment. Could be off my meds. Try to tell you the truth. This always kind of irks me a bit because it's not anywhere near as difficult as you guys think it is. If one thing happens and the probability of something else changes, they must be dependent. What's the probability as a man? Well, it depends on if they said no or not. If they said no, it changes. It goes up to 33%. Okay, all right. So let's see. What we got? Oh, we got a little bit of time. I'll tell you what. Let's finish this next time. That's fine. We were all up on that independent stuff. So maybe read the textbook about that. Try to get some more examples. Clayton? Leilani?